Hello and welcome back to the Programming Bootcamp. My name is Gabor Sabo and welcome back, Nora.
Hi.
In this video, in this episode, we are going to talk about Pandas, one of the libraries that is used by data scientists and scientists in order to deal with, I guess, primarily Excel slide or CSV style files. Regular data that you have and you would like to analyze. So let me try to show you in the slides. We get to the Pandas chapter, which is just after sort of after the NumPy and then in the SciPy area. Pandas is a Python data analysis library. I don't know really why it's Pandas actually, but the idea is that you have some data sequences that you would like to handle. And then for the demo, so I'm going to show a couple of demos, basically two main ones. One of them is a set of some data about planets, and the other one is data from the Stack Overflow survey. Okay, so the planets data is just a CSV file that looks like this, that has 3 columns, basically, the planet name, the distance in AU, and the mass of each planet, okay? And astronomical unit, the AU, okay? And then there's just a CSV file. The Stack Overflow survey, and I should really check it. I don't have it on the computer because it's in the slides because it's too big. So let me show you. So the Stack Overflow, and let's download it. The Stack Overflow is, if you recall, is the website where you can ask questions and programming questions, and lots of people answer. And many times you already have success with already getting the question and the answer without you asking it because someone already asked. And every year they have a survey, like since 2011, ask all kinds of questions about the programmers, and then they provide a full, I guess maybe cleaned a little bit data set, so they remove the private information if there is anything, but they provide this data set in a CSV format. So I can click on this. And well, so far, I always try to download it in my Linux machine. So we'll see how it works with this Windows. I guess there's where I need to download it. Yes, it's downloading. Okay. And well, let's go to the. Let's open another version of the File Explorer and go to the download directory. I guess it's saved in the download directory. Here is the developer survey, and I can extract all. So it's just a regular zip file. Okay, nothing special there. I just have to, one thing that people encounter is sometimes they sort of double click on the zip file and then try to work on the zip file. So double click, and their sort of Windows shows them the content, okay? But they're not really on the disk, so then they can't open it. Okay, so let's take this directory now. Okay, actually, this is the directory that was opened, and this is what I wanted to show, that sometimes people click on it, and then they sort of see as if they see the content, but it's just Windows pretending to, Windows showing what is in the zip file. And the zip file is not really open. So other tools can't actually get to the files because it's just, so I took this directory that was created when I unzipped it, and I'm going to just move it to the same directory where the source code of of the slides are. So it's going to be easier for me to find the data, but it's just, that's that. Okay. And if we look into this directory, what you can see here is the actually results, the analysis they provide, and some README file describing what's in there. This is the data set. Okay, you can see it's quite big. Okay, it's 92 megabyte of data, and I think this is just showing the list of the title. Sorry, Windows trying to convince me about something. Okay, so this file, the schema file, contains, I think it's just a list of the titles. I think this one I can easily open with Notepad++, and this is the name of the column and the actual question. So just in order to make it easier to understand what's in the data. Okay. And the other one, I guess, I don't know, I don't want to open it with Notepad++. I guess it could be open, but it's just a big CSV file. Okay. Okay, so let's get back to the slides. I don't need this one anymore. And here are the slides. Okay, so let's start using the two data sets. So in order to load pandas, I usually say import pandas SPD, because that's the industry standard to call pandas. Instead of using the name, we are using the PD. And this is just plain regular Python code that we already saw, just to get the name of the file. And here I have the name of the Planet CSV to make it easier for me to run the code without typing in any file name. And then we call the read CSV method of pandas. So we don't need to use the CSV libraries that we learned in some earlier video, because pandas itself has its built-in way of reading CSV files. So you get, you give it a file name, and what you get back is a data frame. You could call it anything, but most people in examples usually call it a DF. So it's because it's a data frame. And then you can just go ahead and print it. So if I print out a DF, then I will get something like this. Okay, that's for the planet. So let me try to run this now, so we can also see it. Python running. It's called read CSV. And if I just run it, then it opens that file, the planets file, and shows it. But I can also give it the name of the data set. Data. You remember the name of the directory? It's called developer survey. Developer survey. And inside there is the file which was called survey results public CSV. Okay, so if I run it on this one, then, well, you can't see that much, but what you can see here is that it shows the titles of the columns, but then it says 3 dots because it can't show all the columns, because I think it has like 70 columns, or I don't know. Maybe at the bottom it says, yeah, at the bottom it says it's 61 columns and 64,000 rows in this data set. Okay, and it doesn't show all the data. It just shows you, okay, this is the beginning of the columns, the end of the columns, and then here are the rows also. It shows the beginning and the end only. So I guess if I enlarge this, then it's going to be a little bit more, a little bit clearer. Okay, so it looks like a table now, but still it just shows a really small subset of the data, because you can't show, and it wouldn't help. And just even this one with the 64,000, 60 something like 4,000 rows, it's a relatively small data set. I think actually the previous year it was bigger, so because more people answered. I think the previous year was 90,000 something rows, but there are even more data with even a lot more rows, and I mean, especially in various sciences. So what I have here is printdf. It just prints out the data for the data frame in a relatively readable way. And then I also printed out the type of it, just so we can see it in 2 different ways, basically. I didn't show you, I think, in the previous parts of the course. You can also, from the DF, you can also get what is its class, and then from that, what is its name, and you use these underscore names. So the type would display something like this, so you can see the full name of it, and the class name would just say this is data frame. It's not that important for now. The real reason I'm showing it is that we know what kind of object we have. So now, for example, you can go and try to search for it. So I say pandas data frame, okay, and then you can get to the documentation of that data frame. So you know what can you do with this object, okay? Of course, you can run dir on this object, and then you get all the methods of it, and so on. Okay, what this the data frame also has, you can run on it a couple of these built-in methods that give you some basic understanding of the data. So one of them is columns, which will just show you the actual list of the columns. Okay, the data types, it will show for each column what is the data type. So when Pandas is reading in the file, it tries to guess what is the data type. And basically, if it sees some text in the column, so for each column, you will have some data type. If it sees some some text in it, then it's going to be a textual column. So it will call it object, I think, here. If it's some integer number, then it will say some kind of an int. And if some of them are floating point, then it will convert them to float. Yeah, you wanted to ask something?
Yeah. What if one of the columns only has like true or false, like boolean thing? Would it?
I don't know if it can recognize. Maybe it can recognize that it's boolean, and then it uses a boolean. So
right.
Yeah, that's a good question. We should add this kind of slides to the slides, so to show them. Okay, so that's what you get from the D types. Index will get you the rows. Okay, how many rows you have. So this file had 0 till 1 row, 0 till 11 the rows. Values will actually show the values of the data. Okay, so that's maybe the least interesting. And then there's the describe that gives you various statistics on the columns where you can have statistics. So they're not the textual columns, the numerical columns. And then it gives you the count, the mean, and whatever statistical thing. That like basic understanding. You can have some basic understanding. There is a count here, which is in both cases. Now in this case, in both 11. But let's try to run this. Actually, let's try to run this here. So what was the name of the file here? It's DataFrame Stats. I think I can't press tab here because then Windows will remove all the rest of the line.
Yes, it will.
Yeah,
I ran into this a couple of times.
Yeah, very friendly. Okay, so this is when I run the same on the. Let me just put a lot of spaces here and run it again. So this is when I run it on the survey. So we can see all the columns here. Okay, the various types. So you can see this int64 and float, and others are object. Okay, and then the data. Of course, it doesn't show all the data. There is NaN. Is not a number. It means not a number, but basically it means all the fields where they are missing, I think. So all the fields that are missing that are supposed to be numbers, I guess. That those are NaNs, I think. Here are the statistics. You can see. Okay. So now in this one, you would see that the count is different for the various columns. Okay, and it's even floating point, which is a little bit surprising to me, but because it's a count. How many answers how many values did you have? Now in our case, each column had a value in each place, in each row. So that's why the number is 11. But in this case, some of the columns didn't have all the values. And that's the reason that the count is not the same. So it's not the total number of rows, but how many had actual data, and not a number, or just empty. Okay, that's not where I wanted to go on. Okay. Okay, more things to do. So okay, so let me now take a little step back and say what we are going to do in this Pandas chapter is we'll see how can we use Pandas to try to understand what the data is. So we'll see various tools in Pandas to make us more make the data more familiar to us, basically. Okay. So in this case, we just use the df head, and the df head will show the first 5 lines of the data, and the df tail would show the last 5 lines, unless of course you give it a number, which means that's the number of lines you see. So here it says that by default shows the first 5, and the tail would also show the last 5, but you can also give a number in both cases to limit the number of rows that you would like to see. Okay, not very complex, but that's what we have. You can select columns that we would like to see. So the beginning of the script is the same all the time. Okay, so here I have df, and then I can address the columns with by their name. Okay, so it's like a dictionary for our purposes. Okay, and what this gives us is a series. It says, if you check the type, it says pandas core series. Okay, whatever, it just says this is the type of the class. It's already quite close to a NumPy array, basically. But this is the series, so this is not a sub data frame. Okay, this is the type of it. You can print it out, and you will just get back the data, and that's it. If you put it in double square brackets, okay, then what you get back is a new data frame that only contains that column. Okay, so in that case, I get back.
Is that a copy of it? So if you were to store the data and then change that.
Yeah, I think you can just say .copy. Well, this,
okay.
Yeah, I think so. We actually also have it somewhere because we're going to mess with the actual data. We'll change it. Okay. And then you can use multiple names here to create a new data frame. And it's good that you pointed it out. This is just a reference to the same data set. It's not a copy yet. Okay. And then this one has 2 of the columns. Okay. And the reason it's interesting that's a data frame or a series is the operations you can do on them. Okay. You can also select rows by addressing them similarly to how you do it in arrays or lists in Python and all kind of other similar places. So it says line number 2 till 5 not included. Okay, so these are these. You can also use actually a method called iloc with similar addressing. So so these are the same these. Okay, and then in the iloc can also get a list of numbers, and then you will select those specific rows. So instead of selecting a range, you can select specific rows. You can't do this with this syntax. Okay. So that's when I guess you use iloc, when you would need to select specific rows and then use that. So what you get back here is just a data frame now, and you can filter out the data to something less. And then you can stack on one on the other these filtering methods. So here you have we have selected those rows, and then within those rows we get these columns. So now we have these smaller data frames, and then here both I just show it with this type, just regular square brackets and with iloc. Right. We can also use filtering in more interesting ways. For example, we can say that select all the values where the mass is bigger than 1. Okay, so this column is bigger than 1. What I get back here is this, you might remember from NumPy, this is the same idea. We get back a boolean column. Okay, and then we can use that boolean column in the df again. Of course, I don't need the variable for that. So I could put just this expression I could put inside. Okay, it's just especially now I wanted to make it clearer that these 2 steps.
Yeah, so you have to write df in the square brackets after
Yes.
df again, right? Okay.
Yeah. So you would have it. This maybe I should create a version where you can see both. But basically, this thing would come in instead of this.
Right. Okay.
So you would have this df twice there. And therefore, maybe it's easier, more readable to do it in 2 steps. Of course, without all these prints, because that's you don't need. Okay. You can also filter columns in a slightly different way. So what we say is that, sorry. I was thinking we are filtering in rows, not columns. The title is incorrect. Okay. So what we're saying here is that all the places where the planet name is well, I could have checked if it's equal, but here I just wanted to have is in. So I give it a list, and then it will get all the rows where the planet name is either Earth or Mars. Okay. So we could have just an equal sign as well to one of the values. Maybe that should be a separate slide. Okay. We can also use other expressions. For example, here we can have this this and this condition. So I have the mass is greater than 1 but less than 100, and instead of using the AND word as we are using in regular Python, here we need to use the single ampersand, which we haven't learned. So there is something called bitwise operations in Python, in other programming languages, where instead of taking the 2 values, we are actually looking at the 2 numbers, saying 2 and 3. Instead of looking at the actually numbers 2 and 3, we look at the binary representation. So 2 is 0, 1, and 3 is 1, 1, right? And then on the second location, they are both 1. So when we try to do the AND, then those are going to be 1, and the others, or the rest, is going to be 0. So 2 ampersand 3 would be 2. Okay, because that's the common bit. And in general, I mean, some areas you need a lot of these bitwise operations, but I think in general programming not so much, except that here we are using that operator. They are overloaded that operator to use to be used in this specific case. Okay. So this way I have created a new selector, which is just a Boolean vector again. Okay, this expression. So it goes over all the columns. So just again to emphasize it, it goes over all the rows. It doesn't matter if it's now 11 or 70,000. We just have this expression, and we don't have to loop for ourselves. We can just write it this way. Okay, so well, now we have this selector vector, and then we can use that selector vector here. And again, this is just a temporary variable that I use, so I won't have a large expression inside the df. Okay, we can also sort the data frame. I say df sort values, and I give it based on which column, and the ascending or descending order, and I have no idea what else you might give to the sort value. Okay. Yeah, and here I think I even emphasized, yeah, so this doesn't sort df itself. It creates a sorted df. Okay. Okay, so we saw the iloc method. There is also a loc method, and the idea here, and sometimes I saw it used, and I'm not sure if I'm really interested in it. But if we go back to the way, where can I see it? Read CSV. Okay, so when we read the CSV file, it gave us an indexing. Okay. But what Pandas did is that actually it connected a number to each row. It's not just in the display. They actually have a number. And so when you sort, then you have basically you separated the original row number and the current location of the row because they are now in different order. And that's the difference between loc and iloc. When you're addressing a value based on the current physical location of it, okay, the currently is the third row in the table, or the row that was the third row when you read the file in. So that has the number 3 on the and in the index column. Okay, so
which one's which?
Yes, that's a good question. And where is it? So iloc is that the one that looks at what the physical rows as they are. So when you say I would like to get the third row, that's the iloc. If you would like to get the row that has 3 in the index location, that you would use loc. Okay.
Right,
And
okay.
you can actually see this here because here I said from 2 to 4, and here also said 2 to 4, and the loc gave actually an empty list because the order changed, and what was row number 4 is now ahead of what was row number 2. Okay, because what was number here, so 2 and 4, so because of the size of the planets, okay, or whatever mass, so yeah, the mass of the planets. Okay, because the series is much smaller, and that's the reason. Okay, so because it came here. Okay, so when I say 2 to 4, okay, let me just go back. You can say 2 to 4, and again here say 2 to 4. In one of them it says get me the lines here. This is the sorted one. So get me lines starting where 2 starts, and then search till the 4. But there is no 4, so after it, the 4 is before. And the other one would say they go to the second row, which is 1, 0, 1, 2, happens to be the same in this case, okay? But then go 3 and 4, okay? But don't include the 4. This is also a difference. If you look at this, the loc actually includes both values. So the loc would say, get me the row that has 3 in it, and then until you find a row that has 6 in it, and both of them are included. The iloc would just say, oh, get from third row to the 6th row. And then in the original data frame, it's the same order, so that, but it gets from 3 to 5 only, because that doesn't include the right one. So that's about loc and iloc. Okay, so I guess we'll get back to analyzing more, but now we can also modify the data. So what we have here is we get the 2 columns, and then we multiply the 2 columns. Basically, pairwise we multiply the values. Okay, I have no idea why I multiplied the distance with the mass, but just because I had to do these 2 numbers. Okay. And I get back some value, and I can put it directly back to the data frame. I could just put it in a variable. Maybe I should have showed it separately, just to put it in a variable, and then it's outside of the data frame. But now here I put it back into the data frame as column DM. So when I print it out, now I have a column called DM, which is the multiple, the result of them. And I can also say DF drop, and then give it what column, and I say in place, so it actually changes DF itself. Okay, so I don't have to assign back to DF or not. Okay, so this will drop the column which is called the column mass here. Okay, in this output.
Is that retrievable still, or?
No, you dropped it.
Okay.
Okay. We dropped it and we did it in place, so the DF changed. If I said DF in place false, then the DF wouldn't change, but then I would assign it to some other variable, and then I would get, I guess, a copy of it.
All right. Okay. Okay, but you can't put the single column that you dropped into a variable.
in this type of operation, probably not, but you can,
Okay.
you could,
You
earlier
could
we
do some
see
other way.
how to copy a column from
Yeah. Okay.
Okay. You don't need this line at the bottom. Okay. Okay, so what do we have here? Here we have a calculation. Oh, a little bit of calculation. Yes, this is the point where I was trying to show some actually astronomical calculation that I picked up from Wikipedia. Probably I messed it up also and didn't understand anything. So just think about it, some kind of a calculation. And yeah, here is the actually expression. So it says that the gravitational force is G times the two masses of the two objects divided by the square, right, of their distance. Okay, that's sort of the gravitation. So let's calculate this one. And what we do is we say, okay, we pick up a center. So this is what I would like to do is create a column where you can see all the gravitational forces of each planet related to a single specific planet that I decided, which is the center of the world for our purposes. Okay, so we can put it in a variable, so just so it can be easily modified if we decide that the Earth is not the center of the world anymore. Okay, and I have the name of the file, and I think I actually even allowed here to the user to provide a new value for the center. Okay, and then we reduce the data. So here we have the comparing the planet name with the center, and we fetch the row where the planet name is the center. Okay, now if this was a table where you had the same planet multiple times, that would give you multiple rows. But we know the data, that we know that each planet has only one row. So it depends, of course. In the Stack Overflow data, for every country, you will have multiple rows because multiple people from the same country answer the question. So that will give you something different. So this brilliant variable name called this, which is just the current row. Okay, let's just see it. This is the output. Okay, this is the output from it. Okay. Right. And then we take this variable, so this row, and get the, well, we still have to get the single row of it, because it's only us that we know that there is only one row. So we get that row, and we say, oh, so first of all, we said this one, we get the mass of it. Okay, so this is the mass of the center of the universe. Then this is the distance of the center of the universe, because this is the distance from the sun, right?
From Earth, no?
No. So no, what we have in the table is the distance from the sun.
Oh, okay.
Okay, so that's why you can see that Earth is one. Is the so
right.
It's so this is the measurement of how compared to the distance from the. So what is the distance of each object from the sun relatively to the distance of the Earth from the sun?
Right.
Okay. Earth is one. Okay, so but that's basically the measurement here. Okay, so this is the distance, which for the Earth is going to be 1. Then we get the gravitational force that I looked up on Wikipedia, which is just, let's say, 6. I have no idea. This is all in each subject in physics, there's a different number for G. So this is let's say it's 6. Then we get the distance. Okay, so from the distance, the current distance, we destruct the distance of each one of the planets. We get back a vector of all the distances. So the distance will look like all the distances like this. For Earth, it's 0. Okay, and then
isn't that going to cause a problem with Earth when you want to calculate at?
Well, yeah. So let's see. So then I create a copy of the whole DF. so I won't change it. So we can, well, it's just it's also just to show that you can copy it. But anyway, so I have a new data frame. In this data frame, we have everything. And now that we had in the original one, and now we take the data frame from the mass, the original mass, multiply with this mass, and then this divided by distance on the square on the second power, and multiply it. So this is the expression, right? And this is what we get back, the gravitational force, and then we just assign it back to the forces data frame. So we just add it to this column. And then, because I don't want the other ones, I drop the two columns that I'm not interested here. Okay, and I can print the forces, and here is what I get back. Okay, so it says infinite.
Right. Okay.
Okay. You were worried that we have a problem there. Yeah. So it knows how to deal with infinite, or represent it at least. Okay, so that's basically a simple way of taking some data and then making some changes to create a new column that's more interesting, more relevant to your analysis. Where were we? Sorry, there's the planets calculate. Okay, a couple of more examples here. So maybe you would like to read, so just an example that you don't want to create its own index from these numbers, but you would like to use actually the planet name as the index, the identification of each column. So you can use that. I don't know why I had this slide there. I just had it. Count values. Okay, so we can take one of the columns and say count values count, and I don't have the result here. Okay, because it's for the SO. So let's try to do this. But interesting, I lost the example. Okay, SO value. Okay, so this example is specific for the data with the from Stack Overflow, because it's using the country column. And yes, I have to remember, it says developer, and then this is the data. Okay, so this is what it says. It value counts, so it gives you how many of each value you have. Okay, so it says in the country field you had United States 12,000 times, 12,400, and Germany 3,890, and so on. Okay, it also shows you the display only shows you the part of it. Of course, the data structure actually is there. Okay, so this way you can know the distribution of some value. Okay, and then what you got back here, country count, you can access this either as a dictionary by name or as a list by value. And then you know this is the first country, and you don't have to know what is the name. So okay. So now we would like to select the top items, so the top countries. So here we have the value counts, okay, in country, and then I just have n in 20, and they say country count head n. So just as I did on the data frame, I can say head here too. So I get back the first, in this case, 20 country. I can just print them out. The type is a series here, okay. And here I think I just have examples that in different ways to do this. So you can use this head, you can use this iloc, you can say this way. This is all gets you the first n items, and you can get the names here with the first keys. So you can, so it's called SO top countries, SO top countries, and it gives you the top countries and the counts, okay, and the list of the top countries also. So these are the names. Okay.
Can you show the last X number as well.
I guess tail.
Okay, yeah, that's what I was thinking, but I wasn't. Okay.
Yeah. Here too, what I have to say you about pandas, it's huge. Okay, so you will see that each object has maybe 100 methods, and then so it's a huge thing to learn and to get used to. So really, what we see here is just a couple of examples that to get you started with it. Okay. Pandas. Now we are going to show a histogram. So what do we have here? This is still the same. We get the value counts, okay, of the first. So this is just the same as we had the first 20 countries. And then on this series, I say hist, and I can also say the bin size. I think is the how many different drawings to make. So I put it n there, but of course you can change it. Here, sorry, and this is the histogram, and you can display it in different ways, but one of them, what I showed here, is that using the library called matplotlib that we haven't learned yet, but it's there, that says plt show, and you give it actually the data structure from pandas, and it will show you this graph. Okay, and let me try to see if it actually works here on Windows as well. So the name of the script is so histogram. Yes, it seems so. Yeah, it automatically opened this graph and shows you. Okay, so this is nice. You can replace the show with save fig and give it a file name, and then we'll save the image as a file. Because in the end, it's nice. So when you're working on it, it's nice to see it all the time and figure it out what is the graph you would like to have, but then you would like to save it and maybe embed it into your some report or thesis or whatever. Okay. Okay. So there are a couple of things here. One of them is that all this worked, but maybe you noticed that every time I ran this program on the developer survey, it takes about 2 seconds or at least to do it something, okay? And as I said, it's a data set which is not huge, but it's not trivial as well. So it took me almost 2 seconds to actually load the data. That was the most of the time. And I was also sort of lucky because it could load the data. If it had more data, or if my computer had less memory, then it wouldn't be able to load all the data. So there are 2 things here that we need to solve. One of them is to load less data. Okay, if you are going to analyze only the data of a single country, there's no point of loading all the rest of the data, for example. Okay, so that's one thing. And the other thing would be to preload all the data and then interactively work with that. Okay, so the first one we can solve now with just these pandas. The second one, that's what we are going to use the Jupyter Notebook when in a separate chapter, when we are going to see how we can use Jupyter Notebook in order to have an interactive session of this. Okay, I mean, you could also use the interactive shell for this. The Jupyter Notebook is only just a little bit nicer, or a lot nicer than the interactive shell. Okay, so one of the things is that you can say in the read CSV, you can say use columns, use calls, and give it the names of the columns that you would like to load. Okay, of course you need to know what columns there are there, but that's a separate thing. But that's where you can load know which columns to use. Okay, that's selecting a sec. And I guess the way it's reading all the data, but it will discard all the rest that you don't care. It will keep only the columns that you care. The other one is to read basically all the columns, okay, but in chunks, in small chunks. So you limit the number of rows that you read, and then you can actually read just one chunk. So you can start with saying, okay, I have this huge file, just read in 2 lines, okay, but the whole width of the data, and then you can start analyzing what columns are there and so on, and then from there maybe decide what is the what are the columns that are interesting, and then this in the read CSV you can provide both to limit the columns and do the chunk size. So there is a parameter called chunk size, and you give it a number that here I set to 10,000, okay, and this will create you basically an iterator, and then you can iterate over the chunks, so the 10,000 lines each on each iteration. And then each DF chunk, now I call it DF chunk because it's a data frame, but it's only a chunk of it, so it's a part of it. And in this example, what I show you that I call it, and then I run DF, just head on each one of them. So we can run this, hopefully. It's called read file in chunks. Read file in chunks by. Okay, and then you can see that it reads and then displays the head for each part of it. It also shows you one of the line numbers. Okay, so that was that. Okay, so how can you combine now? So we read the chunks, but we only had one chunk in the memory at the time. But you would like to have basically, say, you would like to select certain rows. Okay, so here is the thing that you would like to select certain rows based on some value and maintain and only those values to have in the memory. So what we do here is I pick the country name, in this case Israel, and I say, okay, I'm going to read in the file chunk by chunk. For each chunk, I get that part that I'm interested in. So I was filtering down to only the rows that has Israel in it, or that whatever country that you are filtering for. So this part, this is also so this is a data frame. The part is a data frame, okay. And then what I do is create just a regular Python list and append to it this part, okay. So at the end of this iteration, I will have a regular Python list of several data frames that looked exactly the same, except of the different areas of the data, okay? And then I can say pd concat, and I give it the chunks, and I get back the data frame, which is one data frame where all the data, okay? And of course, if I really wanted to limit something, then I could also put here a limitation of the columns. And then I can further limit what the data I read in. Okay. So this is this is a long one. Read file in chunks, select rows. Okay, maybe I'll just type in read file in chunks, select rows, and then developer survey, and that's kind of that was fast. Okay. So it reads, and what I printed out here, just so we have a feeling for this, is the size of the chunk and then the size of the part. So the size of the chunk is this, and then this is the part that was filtered down. Size of the chunk, size of the part. That was already the smaller. So you can see that the maximum memory we needed was this size for each chunk. And at the end, the total was this size. Okay, so which was actually smaller than each chunk. That's because we filtered down to one country. So this is a way to import data, to load data when you don't have enough memory, and you know already that you can select certain parts of the data. Any questions here?
No, I don't think so, not right now.
Okay. And here I have a couple of more slides that show a couple of things with pandas. So here is just a really simple CSV file. And then I wanted to create a new column that's sort of a combination of two columns. Okay. That's not a mathematical combination. I think the mathematical combination is easy because you can do that on or as we saw that you can add two columns together or multiply them. But if the combination is more complex, and especially I think if it's not mathematical, then I think you can't use that operations. So what you can do then is create a function that does the operation. Let's say this is a string operation of concatenating values, and then you use df apply and pass the function, and you also have to tell it in which direction to work, but that doesn't matter for now. Okay, so this is basically the same vectorization that we had in NumPy. So here we have a function that works on a single row, and then we just apply that function on all the rows. It's quite similar to the vectorization, basically. And I get back a combined row. And here I had the same idea now, just instead of having two fixed names, I have a list of names. And then I'm using some lambda function to do this. The result is the first one is just combining two words, and the second one is combining two words and the numbers also. So it's not nothing really special in this one. It's just slightly maybe more flexible than the previous one. So this also uses the apply. So this is how you can combine several columns if the regular mathematical operations don't work. So far we were reading CSV files, but actually there is also a read Excel. So you can just read an Excel file. That doesn't matter. There is also two Excel. There's also two CSV. So you can save the data. Let's say you filtered out, cleaned the data very nicely, and then you can save it. So other programs don't have to deal with the cleaning part already. They can already have the nicer version of the data. Okay. Here we have, okay, so this is just an example which someone came up with. I don't really understand the genomics behind it, but that was some data from some research that they wanted to have they actually had a much bigger file, like I think hundreds of columns and millions of rows. We just wanted to create here some script that can generate random data, so we can see how can we process it in different ways to make it faster. Okay, and we wanted to have this computation. Okay, and I guess I won't go into this example now. Here we just have some code that the interesting part maybe, I use data time to capture the timestamp before I start running something. And here, this is the just regular NumPy. Using from the NumPy, I'm creating random matrix. Okay, I called it matrix, and I can use them to create the name. Okay, and then I use this lambda function with map and so on to create the genome names, which is just I think it's just M1, M2, and so on, right? M1, M2, M. So I didn't have any special names, just this M1, M2, and sorry, the genome names were G1, G2, and the column names were M1, M2. Okay, and this is how then I convert the whole thing into a Pandas data frame. So I take the NumPy array and I give it what are the index names and what are the column names. And yeah, that's it. And here now you have a data frame, and then you can take that data frame and save it to, let's say, an Excel, because that's what we wanted to demonstrate. The people who brought up this exercise, they had some huge data, which was more or less this format, and we wanted to start playing with the data, but without actually looking at real data, because it was proprietary or whatever. Okay, and so we just generated some random data to be able to create the code for it. And here you also can see that I use the date time to capture the timestamp in each place. So after generating the matrix, after generating the data frame, and then the time for saving because this is actually takes a long time if the file is big, writing to the disk. So sometimes this is the big one, not the generation of the data, because in the memory, it's way faster. It's, I don't know, 100 times faster than getting it to the disk, especially writing. And this is basically how it looks, the data, if you just printed out the data frame. Okay, and then that was how we generated the data, and here is how we used it. So we had this function called calculate averages that would get certain rows and get the mean of each row. Okay, so given a row, it gets the certain columns and then the average of those columns. Okay, so this is the V1 and V2, and then does the rest of the calculation. Okay, and returns the result of it. Okay, and it's important to use the NP log2 and not just regular log2, because the NP log2 works on the vector at the same time. So it's vectorized already. Okay, that's what we talked about in NumPy, that you can vectorize functions, and NumPy already has a lot of them vectorized. Okay, and so this is the calculation, and then this is what we do, what we check. So we check the time and then read the file. Okay, and check the time again, so we can display how long it took to load the file, because that was part of the exercise or example, to see that how long does it take, various things, and then just printing out the head just to see that we have the data as we wanted, and then we run the apply that we saw earlier using this calculation. Okay. On each row. Okay, and then we calculate we have some threshold, and we said, okay, get the data that's above this threshold. Okay, and that's it. So this is just an example of generating some random data in order to, which in case, I guess, I mean, the fact that we are talking genomics here is quite limited connection to being genomics. All kind of other things can be like this. And that's it about pandas. Do you have any questions, worries about pandas?
No, not for now.
Not for now. Okay. So the exercise is, I didn't have any specific exercise here besides, well, go take either the Stack Overflow data. Okay, so this is the general idea. Take the Stack Overflow data, read or look at the results, the explanations they have, which is about the whole data, and then try to recreate some of the same analyses per country, for example. Or I had a couple of ideas here, for example, about open source contribution. Compare what is the relationship between open source contribution and experience. I mean, it's just a data set. You can come up with all kinds of ideas. Alternatively, just pick one of the data sets you already have, okay? Or you can find somewhere and start trying to analyze it using pandas. And you know Kaggle? No?
No.
Okay, so Kaggle is one of the, it's probably most famous of these websites where various organizations share data sets, and then they run competitions, some of them for money, some of them only for fame, for people who can analyze the data set and get back some, not only results, but some predictions for the data. And then, so they provide you the data set, and then you create some algorithm. So they basically, I think that this is how it works. They provide you the data set, the source, and then the expected data, the resulting data. And they also provide a set of data where they don't provide you the resulting data. Okay? And what you do is you do whatever you like to create this, to calculate the expectation. You can basically train your project, okay? If it's a machine learning project, or yourself on the actual data, okay? So whatever you write, you can, the data where you also already have the resulting data set. And once you feel comfortable because your computation gets the resulting data sets quite well. Then you run the same program on the data sets where you don't have the expected result, and you submit the expected results that you calculated. And then they can compare it to the actual data because they have the data there too. And then that's the way how close you get to on the data where you don't have the results to the actual results. Okay, and they have all kind of very interesting data sets. And the other thing, the other nice, really nice thing here is that many people actually submit their solutions, the actual solutions, their code. Okay, so if you start playing with one of these, then you can see how others solved it, and you can get ideas from there. Okay, and maybe not all of them share it, because if they want to win the competition, then maybe they don't share. But you can learn a lot from people, from solutions of other people, of problems that you also thought about on how to solve. Okay, so that's another idea here, to pick something from there. And then there are things like image recognition and I don't know, how can you expect people to actually go to their appointment to the doctor based on various information that they have, so to actually arrive to the appointment, like things like this. Okay, tons of them. Okay, so stop sharing here. Yeah, so thank you for watching, and thank you for asking questions, and see you soon in one of the upcoming videos.
See you.
Bye-bye.